Hi, it's David. We're going to try to emphasize something really important. Intersections are solutions. I'll show you what I mean. Let's take the left side of this equation. LS means left side. That's a line. Hopefully you recognize the mx plus b. That line has a 4 intercept. If x is 0, y is 4. And has a down 1 over 1 slope. So there's the line. The right side of the equation is a parabola. Hopefully you recognize the degree 2 polynomial or quadratic. I might have said left side. The right side, I think I said it right. The right side is a parabola. And we can graph this parabola through its x-intercepts. So this parabola can factor to x plus 2 and x plus 7. Double check my middle term. 2x, 7x. Yep, I do believe that's right. All right. What makes 0? Gives you the x-intercepts. And you get x-intercepts at -7 and -2. Since a parabola has a symmetry line right between all horizontal points, you can determine the middle of this is where x is -4.5. That's the midpoint between those two x-intercepts, which gives us the symmetry line. That's the symmetry line. If I plug in a -4.5 into the factored form, like right here, just so I can figure out, okay, what the y-coordinate is of the vertex. Yes, if you plug and chug the x value, that's the symmetry line, then you will get a y-coordinate. And that y-coordinate will be the vertex. It's called a turning point when you get to calculus. So if you plug in this value, you can see that I'll get a -2.5. That's -4.5 in for x there. Add 2, that's -2.5. And the same thing, put a -4.5 into the second binomial, and you'll get 2.5. 25 times 25 is 625. So I'm going to use the decimal of that and realize that it's 6.25. And that's where you'll find the vertex. The vertex is on the symmetry line, way down here at x is -4.5, and the y is -6.25. 6.25. Cool? So that's how you can get the parabola graphed. I'm just going to try to put in a quick little parabola here. Just a small one. I'm not very good at drawing parabolas on my new drawing board, but I think you get the idea here. Now remember, this is supposed to be about intersections or solutions. I haven't talked about that. Can you see, can you follow this parabola? It's going to intersect the line. And it's going to hit the line at an xy point that I can find from algebra. If I look and follow this blue line all the way up and out, and I follow this parabola up and out, I believe there's some sort of intersection way up there. I don't know where. Let's go find out. If you set this quadratic equation to 0 and solve by factoring, we can find the intersections through the solutions. Now some of you may think, well, it's easy to solve a problem like this. Look, I can isolate this x right here. This has a situation in polynomials where you can't collect your x's. And if you can't collect your x's together, for instance, we have an x squared and a 9x and a -x, and I can't collect those. So that means I can't do the algebra that we learned in 8th grade and 7th grade, 6th grade, etc. We can't do the opposite actions to get x by itself because we can't collect them. So we have to do polynomial solving. which means basically set to 0, factor, and ask what makes 0. So let's set this equal to 0. I believe I can set this equal to 0 by maybe adding x, subtracting 4, and doing that on both sides. I want to do that on both sides. And I will get 0 on the left side. And then I'll get x squared, 10x, that's 9x and the x collected, plus 10. Now I need to solve. So let's try to factor this. I'm looking for factors of 10 that would put this together and make a 10x middle term. So you list your factors, 1 and 10. Will 1 and 10 add to 10? Nope, that won't work. How about 2 and 5? Uh-oh, I do believe this is not factorable. So my whole idea of trying to factor this and ask what makes 0, it's not going to work. So I'm going to show you a cool trick called completing the square to solve. Okay, so when you complete the square, you're going to try to turn this into a square binomial. You're going to turn this into a square binomial. If you're comfortable with binomials, you'll recognize that when you have a 10x, that's going to occur when you have 5 x's on one side and 5 x's on another side when you build the tiles. So you would have 5 x's on one side and 5 x's on another side. And that's how you can get a square. If you've played with tiles, that should make sense. So I can turn this into x plus 5 squared as long as I have the right number at the end, the constant. And I don't. Because if it was x plus 5 times x plus 5, that would be a 25 right there. So I'm going to add 15 to both sides of the equation. When I add 15 to both sides of the equation, the right side is x squared, 10x, and 25, which is the same as x plus 5 squared. Kind of cool, huh? That's called completing the square trick. I love that trick. Now, if you look, I'm only 2 steps away. I can do plus or minus square root to get rid of that square, and then I'll subtract the 5. My answer won't look pretty, but it'll be an answer. So let's see. If I square root both sides, oops, get there. Whoops, did it again. Let's do plus or minus square root on the 15. Always say plus or minus, that way you don't forget the negative. That'll leave x plus 5, and now I'll subtract 5. I think I'll put x on the left just to make it look traditional. If I subtract 5, it'll be negative 5 plus or minus the square root of 15. So you want to know where those intersections were on the x-axis? This one right here looks to be at negative 5 plus root 15. And the other one seems to be way over there, way up there maybe. And that's going to be at negative 5 minus root 15. See, that one's more left. Cool. I'm going to show you another video on how to do this. So check out my folder full of videos. Hope this helps.